So so we have in the first unit, let us talk about the concept map. So this is the concept map of complete subject. So your subject is electrical systems. So electrical systems is being distributed into two segments. First one is the machines, second one is measurementation, and the very first unit there is no major classification, but it has been given like this. So you have basic electrical instrumentation that will go all around all these three blocks. Coming to the first unit, I have already said we have transmission and distribution of electrical power, overhead versus underground system, balanced power, power quality, tariff, etc. And there is one experiment associated with this. So in the upcoming class, I'll tell you how to start the experiment, so that you can you can carry out in the laboratory session, right? See, we have lot of stages in electrical power. So basically the stages has been like very broadly classified into two. Okay, the very first one is power generation. Okay, so how do you generate the power is through different means. Like the means could be like thermal, nuclear. You might have heard about thermal plants, nuclear plants, diesel run plants, wind, solar plants, tidal plants, etc. So wherever the possibility of energy, that is thermal, means you can burn something, get some thermal output through coal. Major fuel will be coal. Then this coal will heat up the boilers. Whatever the water content in the boiler gets heated up, turned into steam, and this steam is basically used for running the turbine. So this turbine will actually transfer the mechanical energy into electrical energy when it is connected with a alternator or a DG, whatever the generators. Okay, and after that you have nuclear. So you use nuclear fuel to heat water. Again, water is the source here, which is converted into steam, and this steam is again passed on to turbine. When the turbine rotates, you get mechanical energy, and when you connect an alternator, so this alternator will actually generate the alternating current or alternating power. And you have diesel. You have a diesel engine. So when you connect a diesel engine shaft to the alternator, so alternator will rotate. So again the same process. So basically in all the cases you require mechanical energy, okay, including the wind, okay, including the wind and the tidal, right? But in case of solar energy, you have sun's radiations that are being basically it has some phenomena that is called as photovoltaic phenomena. So using this photovoltaic phenomena, whenever the sun radiation, okay, that is the light, when light gets imparted on the surface of the solar cells, they will generate electricity. But the problem is solar energy will occupy a lot of space. Okay, you might have seen, no, in a lot of places solar plants. So you have hundreds of acres of land that has been used for constructing solar power plants. Okay, that is all the generation phase. The next one is the transmission phase. Okay, so we have transmission from from production units, whatever that is being generated has to be transferred, right? So generally this is transferred through a large network of wires. Okay, so these network is called as transmission network, right? High voltage transmission network. On the outer region of any city or town, you can see large towers that will carry a high transmission lines. Okay, so those are called as high voltage transmission lines. Once this transmission is completed, whichever town or village or area or an industry that requires this electrical power, since it is a high voltage, they will actually step it down. That is, stepping down is reducing the power basically. So these local distribution centers are called as substations. Okay, it's a low voltage transmission. So whatever the power that is being transmitted, again from the substation it has to be transferred to the local areas. That is called as distribution. So first thing is generation, transmission and distribution. Okay, so this distribution can be done over head, that is through, you might have seen lot of electrical poles in and around your building area or in your locality, or this can be done in the underground. Okay, for large apartments and large building areas, they transfer it underground in order to avoid unwanted space consumption. There are a lot of advantages and disadvantages in both underground and overhead type of transmission. So let us go with how the transmission and distribution happens. I have already been discussing with you, like you have a power plant, they generally call it as power plant. It could be anything, nuclear, thermal, okay, solar, wind, whatever it is. But for windmills, it is basically a large farm, they call it as wind farm. So from there, okay, wherever the generation is possible, you have some different 3 generation units here that has been transferred through network. So this is a high voltage transmission. In this phase, you have stepping up, because transmission there might be some losses. So in between generation and transmission, you have a step up. It has been transferred onto a local distribution station. They call it as a substation. Okay, they call it as a substation. They will step it down there. Okay, so after stepping it down, it varies again. There are different types of substations based upon the power consumption, power utilization. Okay, 33 kVA, 11 kVA, 10 kVA, something like that. You have 22 kVA. So those substations will actually transfer it to the distribution areas for some building area, for industry, for household purposes. Okay, so this is a complete picture of transmission and distribution, like from generation, transmission and distribution. Okay, so let us have an overview. How does this actually happens? First thing is generation. It has been generated at various power plants by utilities and independent power producers. So both private and public sector companies will produce power. Okay, not essentially every time only government will produce the power. Both private organizations as well as public sector organizations, they produce power. Okay, so major things like nuclear power plants are not being privatized because of safety measures, right? Safety measures, nuclear power plants are not being privatized. After that, you have a transmission. Transmission, I have already discussed that it is a vital link that actually happens between power production and transmission. Okay, so it is these lines, they carry high voltages over long distances. You might have seen some things called as pylons. So these pylons will actually, so these are called as pylon, P-Y-L-O-N. Okay, so these pylons will carry the power. I said you have a substation as an interlink. Reason, what is the major reason? Substation will step down. Here it is being step up, it's been step down here, right? Distribution, I have already discussed that electrical farm transmission lines is reduced to lower voltages. So wherever the substation is there, it will actually reduce the voltage, it will lower the voltage, right? So how does this generation happen? Let us have an overview. How does this generation happen? So I've been discussing before starting of this session that it is a mechanical conversion, that is whatever the motion or power that is being generated by different means is being connected with an alternator. Okay, it's been connected with alternator. So this alternator will rotate. Okay, this alternator will rotate in order to give the power. Okay, similarly, when you give same alternator, when you give power supply as an input, in this first case it will generate motion. Okay, exactly vice versa. When it is being rotated, it will generate power. When it is provided with supply, it will rotate. Okay, let us check this hydel plant. Okay, it's a hydel powered plant where the water in the dam will actually power a thing called as turbine, which will rotate. This rotation is being connected with an alternator. Alternator is directly linked with a stepping up transformer on the local production side, right? Based on the water level, the power production will happen. Clear? Any doubts in this? Okay, so I've already discussed with all of the types: hydel, thermal, nuclear, wind and solar. Okay, so these are some types. I'm not giving much idea about all because it's not a part of your syllabus. So here we have something called as transmission. Okay, so let us define transmission. So it's a bulk movement of electrical energy from generation side such as power plant or a substation, okay, to a substation, okay, from power plant to substation. This is called as transmission. What is the problem here? Why the electrical energy has to be transferred from see, you are purchasing a product where it is being manufactured from some location, okay. Let us assume you are purchasing a watch, okay. Watch production is being happened in some electronic city or electronic area, that has to be received by some consumer, then only they'll pay you some money, okay. So similarly, electrical power generation side is one area, and that is the production side is one area. At the same time, you have consumers, that is we, okay, we being the customers, we have to get the electricity. So for that reason only we have a transmission, we require transmission. So there is a lot of struggle involved in transmission and generation, all these things, because erection of these pylons is not a small task, it's a huge task. It requires a lot of manpower in order to build up those pylons, right? So a combination of all these networks, okay, a combination of all these networks is called as national grid. A combination of transmission and distribution together is called as national grid, okay. We have eastern grid, okay, northern grid, at the same time western grid and southern grid. We have three grids all over distributed in India, right? So let us check what is the overview of power system. It has, I have already discussed, so generation, transmission and distribution. Such currents, whatever the currents that are being transferred, okay, will have some what do you call, differentiation or whatever the the types, right? So here we have high voltage lines. They are generally three phase. Three phase means it got three phase differenced voltages. It got three phase differenced voltages. I will discuss in the later class what is this phase and all. In India, we use mostly alternating current as the source. We use a single phase supply, that is 220 volts. Most of you guys know the household supply is 220 volts. The reason, all of your household equipments are designed with 220 volts. That is the major reason. Similarly, in countries like US, they use DC voltage or DC current, right? That is a direct current. Biggest advantage of DC current, this is a very important point in case of like your cities and all, where high voltage current is used mostly for larger transmission. For example, for hundreds of miles, if you want to transfer, in that case you can go with a DC current rather than a AC current, because AC current will always have some losses, right? So they use, in US and other western countries, they use 110 volts DC, that is more efficient, okay. Biggest disadvantage is they have to convert whatever the produced AC current into DC, that is conversion. At the same time, you have generally this electrical supply is a high voltage. I have been discussing from the beginning. It is almost like 115 kVA and above, that is 115 kilovolts and above. This is a very important number, make a note. 115 kilovolts and above. So the average or the minimal voltage, okay, that is being transferred over pylons. There might be a question like this: what is the voltage that is transferred over pylons? Like something like options will be given. So that is 115 kilovolt and above, okay. What is the biggest advantage when you are transferring this huge amount of electricity? There will be reduced losses, less amount of losses will be there, okay, in long distances. So let us discuss about the power system layout.